Hello and welcome back to Unit 11 Day 5's review. So far we've talked about linear, exponential, quadratics. We've talked about what the graphs look like. We've talked about all these characteristics. So now let's move into identifying sequences. Again, we have our linear sequence, which is arithmetic, or our exponential sequence, which is geometric. And if you remember, this arithmetic of A tells us that linear is that same slope. We are adding the same thing each time. Geometric is that exponential. We are doubling, we are tripling, so we are going to be multiplying each time. Or it could be neither. It could just be a random group of numbers. So if it's linear, we need to find the common difference. If it's exponential, we're going to identify the common ratio. So here we go. Part A, we see it's -2 to 4, 4 to -8. -8 to 16. 2, 4, 8, 16. I know I'm doubling. We know then that it will be an exponential function where the common ratio is a -2. Cool. Well done. All right, what's happening? -34, -64, -94, -124. So I see that 30 difference. So then the question becomes, if I have that 30 difference, are we adding 30 or subtracting 30? So I'm going to say -30, and if we think we're adding, let's add 30. Yeah, no. How about -30 subtract to 30? There it is, the -64. And some of us are like, yeah, I have no idea how you did the 30. Take your second term and subtract your first term, -30. You are subtracting 30 each time. So we know this one is a linear or an arithmetic, and it's going to be a common difference of subtract 30, -30. Well done. All right, let's look at this next one. 7, 9, 11, 13. So 7 to 9, we're going up 2. 9 to 11, up 2. 11 to 13, we are adding 2. Adding is arithmetic. Arithmetic is linear. It is a linear, which is our arithmetic, and that is a common difference of +2, +2. Excellent job. All right, this next one, 9 to 3, 3 to 1/3, 1/3 to 9, and that's a 27 on bottom. So in my head, I'm going, okay, well, that's a subtract 6, but that's not a subtract 6. So if we were trying to do the subtraction, adding and subtracting, we take 3 minus 9. And then if we did 3 subtract that 6, does it give us the 1/3? No. So this is not linear or arithmetic. Is it exponential? Take your second term and divide it by your first term. Does that give you 1/3? Yes, it does. So if we have that 1/3 piece, 3 times 1/3 gives us, oh, no, it's a 1. So it looks like on this one, it skipped the 1. So no, this is not either exponential or arithmetic, geometric. It's neither. Now, if this had a 1 right here, then yes, it is. But since it does not, it is a neither. Ooh, that was exciting. All right, let's look at this next one. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So it could be adding 1 to there, but then it drops back down. So again, that's a neither. It's not adding or subtracting in a pattern. All right, let's look at this next one. So we have 100, 50, 25, 12.5. So if we think that this is adding, great, let's go try it. What is 50 subtract 100? So the second term subtract the first term is a -50. 100 subtract 50 is 50. 50 subtract 50 is not 25. So no, that is not true. Well, let's try fraction. Let's try this exponential. Second term divided by the first term gives you a 1/2. Half of 100 is going to be 50. Half of 50 is going to be 25. Half of 25 is going to be 12.5. Yes, we are taking this times a 1/2. If it's multiplied, then we know that that is an exponential function, or called that geometric. So that could be a geometric, where we know that our ratio is 1/2. Well done. All right, let's see. -6, -1, 4, and 9. So if we do that one, we see 1, subtract negative 6. Okay, we're adding 5. Let's see if that's true for all of our problems. Negative 1 plus 5. 4. Oh, good. 4 plus 5, 9. 9 plus 5, 14. So yes, as we are adding 5, the pattern holds. So if it's adding, we have our arithmetic or our linear with a common difference of positive 5. Excellent job. So that, again, is identifying those different pieces, identifying what's happening in those patterns, in those puzzles, so that we can do a full-blown problem. So on number 20, we see, use the following sequence to answer the below questions. Negative 5, negative 1, 3, 7, 11. We need to figure out the pattern. So I'm thinking maybe it's addition. Let's find out. So negative 1 minus that 5 is going to give us that negative 6. Or I'm sorry, it's a negative 5. So negative 1 minus a negative 5 to give us a positive 4. So we think we're adding 4. Negative 5 plus 4, negative 1. Negative 1 plus 4 is a 3. Yep. And if we do it again, we get a 7. Yep. If we do it again, we get an 11. So as you add 4 each time, yes, it does come up with those numbers. So we found that this is a pattern of plus 4. Let's answer the questions. Is this sequence arithmetic or geometric? It is an addition, making it arithmetic. What is the common difference / ratio? The common difference is a 4. What is the explicit formula? Oh, the explicit. Oh, yeah, that thing. So here's where we're going to grab that formula sheet. If you don't have a formula sheet, you may want to pause the video and go find one. You can Google it. It's going to be on the Georgia Milestones Algebra 1 reference sheet or formula sheet. I'm going to pull mine up right here. So you may have this from last semester. If you do, there it is. And you're thinking to yourself, okay, I need to figure out where all these equations are. And I see that I have my arithmetic sequences are here and my geometric sequences are here. Make sure that you use the correct equation at the correct time. So this one, this particular problem is an arithmetic and it asks for explicit. So my arithmetic explicit is right here. My a sub n equals a sub 1 plus that n minus 1 times d. Now, a lot of the times we're going to bring this d to the front. That way it's a little bit easier to see. I like to do that so that way we can see what's going, like when we are distributing that. So that's how I'm going to rewrite it. So we're going to have this a sub n equals a sub 1 plus d n minus 1. And we're like, ooh, yeah, I know what all these things mean, hopefully. Remember, this a sub 1 is our first term. Our first term is that first number. That first number is negative 5. Plus, well, our d is our common difference. That is the plus 4. N minus 1. At this point, we still need to simplify. 4 times n is 4n. 4 times negative 1 is negative 4. At this point, we can combine like terms. 4n. We have negative 5 minus a 4 to give you a negative 9. That is my explicit equation. Excellent work. All right, let's go look at part D. Part D says the recursive formula. So up here we had explicit, and that was that equation. On the recursive, however, it is slightly different. So looking at our formula sheet, our recursive is right here. And this is where we have a lot of notation, totally fine. So I do need to know what is my first term, and then you're going to fill in these pieces. Okay, lovely. Well, I know what my D is. I know that my common difference is that plus 4. We figured it out way up here. There it was. So there's that part. But we need to also know where to start. Well, what is my first term? Negative 5. So I'm going to put a little semicolon between. So as we start writing, there are two parts to this recursive formula. There's this first term part and the actual equation part. And again, this recursive equation is saying the term before plus 4, the third term plus 4, the fifth term plus 4 gives you the next term. Okay, recursive's weird, I know. All right, let's take a look at 21. So 21 says, for the following sequence, answer the questions below. 1, 5, 25, 125. So if we think this is an adding, we're going to take 5 minus 1 because it's the second term minus the first term, and that is going to give us a 4. Well, what is 1 plus 4 makes 5? What is 5 plus 4? Does it make 25? No, it does not. So this is not an arithmetic or linear. It's going to have to be that geometric if it is one. Well, if it's geometric, then we're multiplying and dividing. So take your second term divided by the first term, and we get 5. What is 1 times 5? 5. What is 5 times 5? Ooh, 25, which was my third number. What is 25 times 5? 125, which is my fourth number. So, yay! We found that this thing is being multiplied by 5. If it's being multiplied, you now know it's geometric. If it's geometric, we have a common ratio. Our common ratio is a multiply by 5. Again, geometric has different formulas. Go to the formula sheet, pull your geometric. That geometric is now down here. Again, explicit is the second equation. A sub 1 times your ratio n minus 1. Awesome. So we're going to have this a sub n equals a sub 1 times this ratio n minus 1. Well, I know what my first term is. My first term is a 1. That's my first term in the sequence. It's right up there. And I know what my ratio is. My ratio is what we're multiplying by, times 5. Yay! You're done with your explicit. Starting at 1, timesing by 5. Well done. All right, recursive. Let's go back to the formula sheet. We see that it's a sub n equals r times this a sub n minus 1. Remember, this is a lot of notation with that recursive. So I'm going to do first things first. What is my first term? My first term is a 1. Alrighty, the second part is what was on the formula sheet. We need this r, a sub n minus 1. And I know that this r is going to be my ratio that we're multiplying by of 5. Yay! Well done, us. Next question says the 20th term. The 20th term. Well, I have an equation, and I have a lovely table that'll tell me these interesting things about that. So I'm going to do 1 times 5 to the x minus 1, and I'm going to go to my 20th term, and I see that that's going to be a ginormous 1.9. Yeah, but that's a 1.9 with an e at the end, so pay attention to that. So this is going to be our 1.9073486 e to the 13. Okay? Which tells us, this e to the 13 thing tells us we're going to take this decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Fill it in with a bunch of zeros, and you end up with this huge, ginormous number of 19,073,486, and a bunch of zeros. Okay, there it is. There's your 20th term. Well done. Guys, hopefully this was helpful for you. Let us know if you have any questions, and we are happy to go through everything. Thanks, guys.